So the grid in the United States, anyways, represents about 1,000 megawatt power plants. Now, a 1,000 megawatt power plant is a large power plant. 1,000 megawatt, and if there are engineers in the room, you're going to cringe because I'm going to round and I'm going to use approximate numbers. But 1,000 megawatts is about 1 million horsepower. And so 1,000 million horsepower plants, last time I thought about it, I think that's 1 billion horsepower. 1 billion horsepower on the grid available from a power and capacity standpoint to do the work, take the loads, produce the products that the grid supports. Now, 1 billion horsepower, I don't know if you have any context for what that is, but it's about 6 or 7 million cars revving their engines at full blast to produce about the same amount of power. So it's like a lot of stuff. It's not inconsequential in its scope or scale. And of course, that has to be available 24/7, and it has to be highly reliable. Now, from an energy standpoint, energy is related to, but different than capacity and power. The grid in 2012 and 13 produced roughly 4 trillion kilowatt hours of energy. 4 trillion kilowatt hours of energy. So, anybody got a Tesla? Anybody want a Tesla? They are really cool. 85 kilowatt hour battery, and that's to get you 300 miles. Okay, that's one of their longer range vehicles. I don't know, the math I do says that if you charge that car or those cars once a day and then you used it for propulsion, driving around the rest of the time, you need 132 million Teslas to take the energy output of the grid. So I know Elon Musk wants to sell a lot of Teslas, and God bless him, I hope he does. Hope the price comes down too. But just to give you some scope and scale, this thing is huge, okay? There is a lot of physics, there's a lot of inertia associated with what we're talking about. And that's a little bit of context about what I want to tee up next. So to me, that tees up 2 key questions. One is, Bob, the utility executive, do you see any technologies out there that have the scope, scale, economics, deployability that could replace the grid? Second question is, if the first question has one answer, maybe no. The second question is, do you see any technologies that are out there that could maybe not replace the grid, but still be deployed at sufficient scope and scale to really throw a curveball to the grid in utility and regulatory policy and all that sort of stuff? So for AEP, about 7 years ago, we made a decision that we needed a different data set, a different perspective to try and answer that question in a sober manner. It wasn't that we thought the laws of physics were changing or good engineering practice were changing, but what was happening in particular is the new technologies that were coming out were not being provided by our traditional suppliers. Westinghouse, General Electric, Siemens, Alstom, Brown Boveri. I mean, you go down the list, it's, And as a result, that supplier relationship had served as sort of the feeder ground for the utilities to sort of base their engineering judgments on and their deployment decisions on new technology. So since the suppliers were changing, we felt we had to change our perspective on the input data set we were getting. So we engaged McKinsey. Normally brings fear and trepidation to most industry executives, but McKinsey is a great strategic partner if you ask them the right questions and put them to work. We also took a financial position in a venture cap firm that was focused on energy. So why did we do that? I hope we get the next iPhone or the next iPad, but that's not the reason why we did this. We really did it to get a lens into what was going through a VC's mind in terms of looking at technologies that were out there in the laboratory, how they were making their way through the commercialization space or struggling to make their way to the commercialization space, and give us some insight into what's going on out there in the emerging technology world. And then, of course, we employ our traditional, we use EPRI, Electric Power Research Institute, and the traditional suppliers. And that helped us go through the suite of technologies that I suspect you've all been talking about or do talk about, and that includes solar and wind and microgrids and energy efficiency and batteries and combined heat and power and the like. And I just make a quick comment about each of those and then maybe give some broad perspectives on what we see going on. On solar, how do I summarize it? Virtually everything you hear about solar and the price reductions and the improvement in cost to the consumer, I agree with and I can corroborate. I mean, I think solar is on a real interesting downward cost trajectory. What's interesting and why I think solar maybe differentiates itself from wind and the like is that, and I think somebody on the panel was mentioning this, but we see without any big breakthroughs in terms of the efficiency of the panels or even manufacturing costs of the panels, there's a huge area in terms of installation costs on the roof, standard installation practices that could continue to drive the cost of solar down with or without the impending reduction in the investment tax credit in 2017. So I think there's a real opportunity for solar to be at or within spitting distance of grid parity, at least from a total GT&D perspective, in many, many areas in the United States in the not too distant future, if not now. So there's a perspective. On wind, we've had some very interesting results with RFPs for wind. The machines are getting big enough and the capacity factors are improving sufficiently to the point where marginal costs out of the projects are quite attractive. I just, at this point, don't see wind from a technological standpoint advancing the same way that and having the same opportunities that solar seems to have. And at the end of the day, the wind tends to blow either on the coast or in areas where there's an uplift. And in all honesty, those are not oftentimes in areas of high population, which means you've got real transmission constraints and you probably need to deploy a big transmission build out like the CREZ in Texas to help liberate that resource. So I think it's at the end of the day, that gets into land competition uses and all that kind of stuff and may limit wind at some point. Energy efficiency, huge opportunities. Another technology that I think really resonates to this question about the grid of the future. I mean, not only, we all know about LED light bulbs. I assume there's some incentives in Texas or you've seen incentives to go get LEDs and they're amazingly efficient, better light quality than the old CFLs, by the way. But there's other really neat stuff in energy efficiency that goes to building codes and standards that can really make new construction that much more energy efficient and really contribute to reduced consumption. And then we've actually discovered some neat things and give you an example of one where this partnership with a venture cap firm goes both ways. We actually discovered a particular small company that was could deploy on the grid equipment that would optimize the voltage on the distribution system, which I'll just say allows motors to run more efficiently if you can optimize the grid voltage. And as a result of motors running more efficiently, you can in effect have a 2 or 3% reduction in the consumption of electricity on the grid by optimizing grid voltage. So there's lots of neat things out there in energy efficiency space. Microgrids, very, very interesting concept, expensive as hell. So something has to break there in microgrid land to make the value proposition of being able to isolate and go off grid be something. You're either going to pay for it right now because you have an incredible value proposition for reliability. But if you need more than that, you're going to be really faced with some high prices to get microgrid deployed. And that's going to, maybe over time that will change and that will happen. As a matter of fact, I relate to you that we've spent a fair amount of time talking to the military because of mandates from Washington about, either energy efficiency or microgrids and the like. All love the idea, can't figure out where to get the money to pay for a microgrid. And quite frankly, if you look at the United States, the number of microgrids that are out there are few and far between because of that cost factor.